Hello, welcome to another video here from Mr. Parr. Today's video is going to be about how to find the equation for a linear graph. So if we're given a linear graph, how to recognize it, how to get its equation and write that in the form of y equals mx plus c, and we're going to learn what this means throughout the lesson. So before we can get started, just give you a heads up really. To understand what's going to be happening today, you need to have understood what gradient is. Now, I've done a video on this, so if you want to go back and watch that, that's perfect. And what the y-intercept is, I'm going to cover this lesson actually as well, in this video. But it's great if you already understand it. And substitution, you definitely must understand how we substitute values into an equation to, well, find answers and calculate things. Now, equipment. If you want to be able to do this, you don't have to have these things, but if you do, so you can sketch things out and muck about with it, it would be helpful for you to have a square or graph paper, pencil and a ruler. All these things would allow you to draw out graphs and be able to mess about and try your own thing. Now, before we get started, I just want to, for those of you not sure what I mean by a linear graph, just want to quickly introduce you to these. Now, a linear graph is any graph that forms a straight line. So one straight line as a graph is what we would call a straight line graph. Now for some reason these numbers have disappeared up here. So my graph here, or my axes I've done here go from 9 to -9, left to right, up and down. So on the x-axis and on the y-axis. And each of these is what I would call a linear graph, but they've been written in different ways, in slightly different ways. This is, but we can interpret these quite easily. If you look at this, this is telling me that a graph, that when I add the x-coordinate and the y-coordinate, I will always get an answer of 8. So we can think about that quite easily if you think on those grounds. So let's look at it simply. I could sketch this very quickly. I can see immediately that this graph is going to go from here all the way down to here, passing through the points 8 and 8. And we can even prove this by, if we go along, if I take the coordinates of this point here has the coordinates of 1, 7. So the x value is 1, the y value is 7. If I substitute them into this, 1 plus 7 is 8. It works. Let's pick another point. There. This has coordinates 3 and coordinates 1, 2, 3, 4, 5. 5. 3 add 5, 8. So it works. You can pick any two points. You could even, if you could read them off, you could even take those points. So that there is 1, 2, 3, 4, 5, 6.5. That there is 1.5. So the coordinates of this point here are 1.5 and 6.5. Add those together, you get 8 still. And if I could read it off and take other decimals, those would also work. So they all work for putting into that equation. So there's those. Now, I'll just rub these out because they're going to get in the way otherwise. If we would then try the red one, 2x plus y equals 4. Again, I can plot that. I know if that's going to go through over here at 4. And so we could pick points. So can you think of two values? Well, I'll tell you what, rather than me doing it, can you pick two values? I'll try and pick 2 as well. What would work? What could I put in here, double it to get me 4? Well, an easy way we could think of it, well, what if x was 0? Well, if x was 0, we'd be doing 2 times nothing is nothing, and y would equal 4. So when x is 0, y is 4. So we got that point. Equally, well, what would happen then if y was 0? Well, if y was 0, 2x would equal 4. Therefore, well, 2 times what is 4? Well, 2. So then x must be 2. So when y is 0, x is 2 over here. Then we've got a straight line. Join 2 points, you get a straight line. So let's do that. Now ideally, our straight line should really carry on in both directions. And it will. It will absolutely work. And we can try this. But anyway, I don't want to go into this too much or get this too confusing. And I could do the same for this graph. So y equals 3x plus 4. I can see that that is a line that comes from here down. Now, I just wanted to show you this, that even though each of these are written in different ways, you don't have to understand what I've just shown you, that each of these are written in different ways. Each of them are a linear graph. But what's brilliant is, every single one of them, if you understand how to manipulate an equation, can be written to look like this. And this is the best way to write any linear graph. It is really easy to plot. When you've got them like this and like this, it can be a bit, well, a bit complicated. It's not an easy way to do it. This for us is by far the best way to write it. And we call this the intercept form. And we say that it's written in the way that we call it y equals mx plus c, where m is the gradient of the graph, which you should know if you've watched my previous video about gradient, is how steep it is. And where c, let me just circle this here so you know what I'm talking about. So it's just the m, not the x, just the m is the gradient. And where c is the y-intercept. Now what I mean by y-intercept, just quickly go back to the last slide. Oops. The y-intercept is where the graph crosses over the y-axis. So at this point up here, where I'm hovering my mouse now. That is our y-intercept. So with that in mind, I'm just going to go to a web page now called DESMOS and show you how this works. So, oh, wrong button. That one. There we are. So let's just quickly move this out of the way. Now I'm going to start with the graph y equals 2x plus 1. I can tell by looking at this that I know this has a gradient of 2 and a y-intercept of 1. Let me prove that to you. If you come over here and I click here, where it crosses the y-axis, do you see how the y value is 1? Just like it is here. Now I'm going to go to y equals 2x plus 2. The gradient's the same, but I've changed this c value at the end. And if I turn that on, you'll notice that the steepness of the graph has not changed. Just like I said, this value here, this value here is the gradient, as is this one. So they've got the same steepness. But by changing this value, I've changed where it crosses the y-axis. Now if I turn this third one on, what do you think that's going to do? Where do you think that's going to cross? Yep, it's going to cross at 5. Up here. It's going to cross at 5. And there we go. So by changing this c value, I change where it goes. I mean, I'll even change it here. Look, let me change it to -5. There you are, look. It's dropped all the way down. Same graph, or same steepness of graph, but now it's crossing at -5 instead of +5. If I change it to -3, there we are. Now it crosses at -3. Easy. Doesn't change the steepness, just changes where. So it moves this graph up and down by changing that. Now, if I turn these off, and now I'm going to look at what happens if we mess with the gradient. So you can see this graph here, in combination with this graph here. Oh, this one. I've kept the y-intercept the same. And now I've messed with the gradient. So this will still cross at 1, but the gradient is going to change. Watch. It's steeper. This purple one is steeper. And we can see that if we wanted to by calculating the gradient. If I picked a point here and a point, oh, I can't get a nice whole number up, here we are, 2, 7, I could use those coordinates and work out the gradient. And I guarantee you, if I worked that out, I would get an answer of 3. And that's why it does what it does. Why this number here is 3 is because that is the calculated gradient that we did in the last video. Now I've got another one. This is 4x plus 1. So again, I've kept the y-intercept the same, so we know it's going to cross through here. But is it going to be steeper or shallower? Well, it's going to be steeper because it's a higher value. It's going up. Even steeper still. You can see that black is steeper. So, now I've done a random one down the bottom here. And I'm just going to mess with this just so you can play along. Have a guess at each thing as I change it what's going to happen. So, I'm going to delete this and turn that back to 2x so it matches the original. Now, if I change this to 1x, you can see it's shallower. And I'm going to delete this away completely and turn this into plus 0. And you can see it goes through at 0 and it's got a gradient of 1 because it goes cross 1, up 1, cross 1, up 1, cross. So the rise is 1 and the run is 1. Now, let's change this. So I'm going to change this 0 and I'm going to change it to a 4. Is that going to move the graph up or move the graph down? Have a think. Change it to the 4. It moved it up. Okay. Now I'm going to change this, take this 4 and change it to a -2. Is that going to move it up or down? Absolutely, it moved it down. Brought it down to -2. Okay, right. So, let's change something else now. Let's change the gradient. So I'm going to keep it at -2. In fact, I'm going to turn off this original now. And I'm going to change the gradient. If I change that gradient to a 3, what do you think is going to happen? Think about it. Okay. Change it to a 3. It got steeper. See, here's our original. I'll put a -2 here to show you the original. So our original is that one. And this is our new one, this steeper, lighter red line. Okay, let's try another one. What about if I made it a half or 0.5? What would that do to it? Well, being a half is less than 2. Being that a half is less than 2, it should make it more shallow. And it will. So it's even shallower still. Now, I'm going to turn this one off. I'm going to bring this one into play, this blue one. I'm going to put it as -2 again. Watch what happens when I make this value negative. In fact, what do you think's going to happen when I make this value negative? When I change the gradient to a negative, what do you think's going to happen? Okay, I'm going to keep it as a 4. I'm going to change it, this here that we've got on. I'm going to change this to a 2 so it matches the other one. But I'm going to make it a -2. There we go. There's the -2. And the red one is the +2. Same steepness, you'd argue, but one's going uphill and one's going downhill. So this downhill one is the negative. And we should remember that from the last video we did on gradients, that negative gradients go down as we read a graph from left to right, and positive gradients go up as we read left to right. So, back to our PowerPoint, back to our screen here, not PowerPoint, sorry, that's what I'm used to doing elsewhere. So, this would then allow me to spot things on other graphs. So for instance, this should allow me therefore to find or recognise a graph or the difference in two graphs. So for instance, I'm going to draw two graphs here. I'm going to draw one there, and I'm going to draw another one in red, and I'm going to put it in this direction. Now, one of these graphs is y equals negative 1x plus 7, and the other one of these is y equals positive 1x plus 3. Now there's two ways I could tell these apart. Very quickly, with the first way, well, they have different y-intercepts. One has the y-intercept of 7, one has the y-intercept of 3. There we are, there's the one with the y-intercept of 7, there's the y-intercept of 3, so I know which equation belongs to which instantly. But what if they didn't have the same y-intercept? What if they had the same? So what if I drew this line again? Oh, that's wrong. But now made their y-intercepts match. So now they both have a y-intercept of plus 3. Now how do I tell them apart? Well, it's got to be the gradient because they're not the same steepness. One is going down, which we know means negative. Ah, there we go. And this one's positive. So therefore this top one, this top equation must be that blue line there. And this bottom equation must be that one there. So we could tell them apart by having positive and negative gradient. But, again, let's try something else. What if, this time however, they're both positive gradients? So what if, I'm going to do another one up here, bring it through there. Just quickly rub out these y-intercepts to make them the same. Which is which now? They've both got the same y-intercept, so that can't differentiate them, because they both go through the same point on the y-axis. So it's got to be the gradient that tells them apart. Now this has a gradient of 3, and whilst this doesn't have a number here, I know that that is a 1. We haven't written it there, it's an invisible 1, but it's still there. So 1x and 3x, so which one's steeper? One line is steeper than the other out of these two. Let's get rid of that other one so we don't confuse things. Well, the blue one is obviously steeper, so that must be this one. So this one must be the blue one, and this one must be the red one. Done. Quick ways to be able to separate between two graphs. If I really wanted to, you could have used the skill that you might have learnt in my other video, which is calculate the gradient, and I could have picked 2 points, so this point and that point, drawn on my triangle, and I could have actually calculated its gradient. This is the better way to do it. So this has got a run of 2, 1, 2, 3, 4, 5, 6, a rise of 6, and gradient, as you should remember, is rise divided by run, which equals 3. And there we go. Gradient of 3, rise of 3. It's just a coincidence that this is also a 3 because it's going through at the intercept point of 3. Don't let that catch you out. Now, before we move on, I've got a few questions for you to have a go at, and here they are. So I've got 6 equations, 6 graphs on a set of axes, and I want you to match the graphs, the equations, sorry, to the graphs. Pause the video, have a go, and when you're ready to move on, press play again. Okay, I assume now you've answered those by now and had a good go. So, we can see, if we look over here, there are some graphs that have the same intercept. So we've got a pair here that have the same intercept at 7. So can we pair those together? Yep, there we go. There's those two. That's nice. They're sat side by side. and there's another pair of graphs going through at 1. Well, that must be those two. Those who aren't sure why, you've got, I'll just highlight that in green. See, plus 1, plus 1. If I highlight this in yellow, plus 7, plus 7. So I know those graphs belong to those lines. And then the last one, well, being the only one that doesn't match, that's at -9, and this goes through at -9, then this must be graph E. Done. If I really wanted to, I could have then also calculated the gradient to see if the gradient matched the 3, which it does. Now, let's differentiate these two, so the two yellow ones. We've got a red graph and a green graph, both going through at 7. One is steeper than the other, so which has the steeper gradient of these two? Well, it's the bottom one, isn't it? Because it's got a gradient here, it says of 4. So C, that red line, must be this one, meaning the other one must be graph A. This line running up here through that 7. Now it's just a matter of distinguishing between these two. One has a gradient of 2, one has a gradient of 3. So which is the steeper gradient? Well, it's the black one. So that has a gradient, so that must be graph D. And this must be, well, what's left? We've got A, oh, it's B. Must be B. It's the only one left we haven't used. And if you want to check, you can see B goes up through 1, and it is shallower than the black one that goes through at y-intercept of 1. So there we are. There's our answers. Now, how do we then find the equation of a line that's not given to us? Easier than you might think. So I'm going to draw a graph on here. I'm going to create one like this. There we are. One graph. And I know, because this is a straight line, that it must be in the form of y equals mx plus c. Now, to make this equation, I need to know the gradient, and I need to know the y-intercept. Well, that's the easy bit. Y-intercept's the easy bit. We just go over here, and there it is. So 1, 2, 3, 4, 5. So as a y-intercept of 5. There we are. So c is 5. Gradient we've got to calculate. So as you remember from the last video, just pick 2 points. 1 point there. And again, we want nice whole number points. So I'm going to make a line. Make a nice triangle that has a height of 4, a width of 2. So therefore we do the rise divided by the run, which gives us a gradient of 2. So we've got a gradient of 2, a y-intercept of 5, which means the equation for this line is y equals 2x plus 5, because it's positive. Let's try one more. So let's do a downward one this time. In fact, I'm going to move that and bring it down to here. There we go. Right. So let's try this one. So again, we know it's got to be in the form of y equals mx plus c. We need to find m and we need to find c. C again, straight away, just go for that. So 1, 2, 3. So that's got a c value of 3. Gradient, again, pick 2 points. I'm going to pick this one here and use the one I had for the y-intercept and make a right angle triangle. It's got a height of, now, this is where you've got to be careful. Don't forget, 1, 2, 3, 4, 5, 6. So we've got our rise of 2 and run of 6. Now be careful with this, because is this still a rise? If we remember, graphs we read left to right. This graph isn't going up, it's going down. So if a rise is positive, then a fall, don't forget, is negative. So this is minus 2 over 6, which simplifies to minus 1/3. So this graph has a gradient of a negative third, and a y-intercept of 3. So I'm just going to substitute those in and make the equation. So y equals minus third times x plus 3, because it goes through at positive 3. If this line had gone through, if I had taken this same line and had actually crossed it down here, let's say at minus 4, the gradient hasn't changed. All I've done is shifted the graph down. So it would still be y equals negative 1/3 x, but now it crosses at minus 4. I would put minus 4 here instead of plus 3. I hope that helps. Now, before you go, if you want to have some practice of this, again on the next slide, I've got 6 graphs. From each graph you can make an equation. Pause the video, have a go. This is where your pen and pencil might come in easy, because if you could draw these out, you could draw them on. You might be able to see it on the screen, but it's up to you how you want to do it. Press play when you're ready to get the answers. Okay, so let's go through these answers. I'm going to do A first. So A, I can see immediately has a C value of 1. So C equals 1. And the gradient we're going to calculate with our triangle. So let's make a triangle. Goes across 2, down 2. So that's a run of 2, a rise of minus 2. So that's minus 2 divided by 2. Rise over run, which gives us minus 1. So this is y equals minus 1x plus 1, because that's positive. Now this can simplify, because we don't need to say minus 1, we could just say minus x plus 1. Done. Right, next graph B. I'm going to go for black pen on this. This graph is black, so again, now this goes across at 1, 2, 3, 4, 5, 6. So this has got a C value of 6. M, again, I need to pick some points. So I'm going to pick this point and this point. Goes across 2 and up 2, so it has a rise of 2 and a run of 2. So that's rise over run, which gives us 1. So this one is y equals 1x plus 6. So it went through at 6. Okay, C. Where is C? Where's that hiding? Oh, did I miss C out? Alright, let's not do C. So we're A, B. I did 2 E's. Right. So let's change this one here and call this one C. Right. So C. Again, you can see it has a y-intercept of 1. And M, pick 2 points. I'm going to pick this point and this point. Do a triangle. It's got a rise of 1, a run of 2. So remember again, it's rise over run. Oh, well, we can't simplify that. The gradient is a half. So this is y equals 1/2 times x plus 1 for the y-intercept. Done. D. Y-intercept. I'm going to start shortening this of minus 3. So I know it's y equals some multiple of x. And it's at minus 3, so I'm going to put minus 3 for the y-intercept. To get the gradient, I need my triangle, so I'm going to pick 2 points. There's a point, I'm going to use that with the y-intercept, because I've already found that point, which is there. So this has got a run of 2, a rise of 4, so that's 4 over 2, which equals positive 2. So that's 2x minus 3, and the last one, I'm going to do that in green because that's the colour of the graph. Again, has a C value of minus 3. Get its gradient. I'm going to do points over here so it doesn't get jumbled in with this work. So I'm going to pick that point with that point. Is that the right graph? No, we've already done the red line. We want the green line, don't we? So this point and that point. Draw my triangle. Green line we're after now. That's got a run of 1, a rise of 3. So as we know, gradient is rise over run, which gives us a gradient of 3. So this is y equals 3x minus 3, because it went through at minus 3. Done. And there's your answers. I hope this helps. Thanks for watching, and I hate to ask, but if you enjoyed the video, please click and like, and take care.